Okay, so let's get started on this where we're going to talk about similar figures and proportional reasoning. Now remember, what's the difference between a similar figures and congruent figures? Congruent figures are the same exact size and shape. Similar figures are the same shape but proportional sides. Now, when I take a look at this, I can look at the triangle on the left and the triangle on the right. And what I notice is that the side of length 2 in the little triangle corresponds or matches up with the side that's 4 in the big triangle. The side that's 4 in the little triangle corresponds or matches up with the 8, and the 3 with the 6. And it's worth noting that every side in the bigger triangle is twice as big. And that's what we mean by proportional, right? 2 times 2 will get you 4, 4 times 2 will get you 8, and 3 times 2 will get you 6. But we should be able to set up a proportion, and that's what we do here. It works for all the sets of sides. 2 is to 4, as 4 is to 8. And clearly when we cross multiply, I would get 8 equals 8. Or 4 is to 8, as 3 is to 6. Again, little is to big as little is to big. Cross multiply, and they're the same. Now, what I said a moment ago was, in my best British Mick Jagger accent, little is to big as little is to big. The side of the little triangle is to the side of the big triangle as the side of the little triangle is to the side of the big triangle. We do stop and start here, where you stop, and you start and begin the problem without me, and then you stop when you're done, and you keep on playing, and then I'm only going to pause a couple of seconds so that you can get started. So, start and stop. Okay, now, what we mean by this is the 3 corresponds to the 12, and the x to the 20. So 3 is to 12. That's my ratio there. Has to be the same as the ratio of the x with the 20. And when we set those ratios equal, we have a proportion. So 3 is to 12 as x is to 20. We cross multiply, also known as the product of the means equals the product of the extremes, if you want to get real technical with your language. 12 times x is 12x. 3 times 20 is 60. Dividing by 12, and I get x is 5. So once again, going back and summarizing this, when I have similar figures, I like to approach the problem through the viewpoint of the little one is to the big one, as the little one is to the big one. And then I cross multiply once I establish the proportion. Okay, give it a shot. Okay, so this time, little is to big as little is to big. The 5, I should say, corresponds to the x, and the 4 to the 8. So 5 is to x as 4 is to 8. I cross multiply. 4x is 40. Dividing by 4, x is 10. And that makes sense, right? Because 5 times 2 will get you 10, and 4 times 2 will get you 8. So there's that consistency from the first problem. Now, sometimes we like to find or see similar triangles within a diagram, like here. Read this over. Find the length of BC. Again, stop, start, and we'll go from there. Okay, so little is to big. I always forget. I have to put the x in here on BC because that's the length they're looking for. Now I get to sing, little is to big as little is to big. See, I do that on purpose to annoy you. And by annoying you, now what happens is that song is stuck in your head. Kind of like that really annoying French song, Frère Jacques, Frère Jacques. Oh, God, I hate that song. Or the American one that's really annoying, John Jacob Jingleheimer Schmidt. Our really annoying one for this course is little is to big as little is to big. But if that annoying song, and they make some commercials annoying so that you'll remember them, well, that annoying song will be remembered on your test, and that's what I'm looking for in making such an annoying tune. All right, little is to big as little is to big. The 4 corresponds to the 10. Those are both radii, right? And then the 5 corresponds to the x. So 4 is to 10 as 5 is to x. I cross multiply. 4x is 50. I divide by 4. X is 12.5. And choice 3 is the correct answer. Now, let's take a look at this diagram that shows triangle ABC similar to triangle ADE. That's that symbol in between the two triangles up top there. That's the similar figure symbol. And we now need to make or find X. And this can be a little tricky, and it's worth stumbling around a little here in case you get it wrong. So I'm going to pause. You're going to do stop and start, and then we're going to go over it. Okay, so they want side BC, and we begin with this foundational way of looking at things, this similar figure glasses, if you will, of little is to big is little is to big. So the 4, in one sense, yes, it matches up with the 8, but the problem with that is, for the big triangle, and this X here, this is on the big triangle, so I have to take the side of the big triangle, which is not just 4 for the little triangle, and it's not just 8 for that trapezoid on the bottom. The side of the big triangle, I'm sorry, is actually 12. It's the 4 and the 8 summed or put together. So the 4 is to 12, not to 8. 4 is to 12. It's the whole length we're looking there because that's the side of the whole big triangle, right? You have the little triangle ADE and the big triangle ABC. So 12 is the length of that side for the big triangle, as 10 is to X. Cross multiply, 4X is 120, divide by 4, X is 30. So we really have to pay attention to, are we going to use the X as part of the big triangle? And if so, then we really have to use the length of the side for AB to be the length of the big triangle. Okay? Now you try this one. And notice something here. The X that we have represented for finding EC, that's just a part of the trapezoid. Okay? It's not, if we, I could have made the X the whole length AC, but I only made it the part of the trapezoid. So now I can work off the 10. Go ahead, stop, start. Okay, so on the left side, little to big here, and we say little is to big, but what we're really looking at is 8 is to 10, the trapezoid being a little bit bigger than the triangle, as 12 is to the X, okay? Cross multiply, 8X is 120, X is 15. It's very important that we emphasize that we're not dealing with side BC. If we dealt with side BC, that is strictly to the big triangle, and then I would have to do the 8 and 10 together to get 18 for that side. Okay? All right. Now, one more question to take a look at. Diagram below, triangle ABC is similar to triangle ADE, so that similarity means in which one of these, when you set up the little is to big is little is to big proportion, does it actually work? Stop, start. Okay, so we could try all of these, but the one that actually works when we consider that the whole length is 6, and this is 2, and the whole length is 5, and this is 15, when I substitute them into little is to big is little is to big, only the fourth choice works. If I cross multiply here, I get 30 equals 30. If I try any other combination, it does not work. It won't cross multiply to have the same value. So choice 4 is the correct answer there.